Welcome to Building Reddit. I'm your host, Ryan H. Lewis. Experimentation might not be the first thing you think about in software development, but it's been absolutely essential to the creation of high-performance software in the modern era. Pretty much every product or software company has created some kind of implementation of A/B testing or an experimentation platform. At Reddit, we use our experimentation platform for fine-tuning software settings, trying out new ideas in the product, and releasing new features. What impresses me about it is the fact that each code path or user request can evaluate hundreds or even thousands of different experiments. The experimentation platform we have has to support that, and that kind of capacity is mind-boggling even on a site of Reddit's scale. So I wanted to understand how we did experimentation at Reddit, and there was no one better to talk to than principal engineer Matt Knox. Among other things, he's been driving the vision behind experimentation at Reddit for over 6 years. Here's our conversation. So what is your name and what do you do at Reddit?
Hi, my name is Matt Knox, and nobody actually knows what I do at Reddit. When I started at Reddit, I asked my boss. I said to them something along the lines of, "Hey, so like I work here now, but we never actually said what I was going to do. So what is it that you want me to actually do?" And he said, "Just go make Reddit better." And that's why my job is the dopest job in tech. It's just amazing to have so much scope in such a large and important company as Reddit. And I'm extraordinarily lucky to be able to do that.
That's awesome.
Yeah.
Any specifics beyond that?
Yeah.
So it's very broad.
Yeah. So I do kind of a broad grab bag of things. The most sort of down in the weeds code thing that I'm continuously responsible for is Reddit's experimentation infrastructure. So that's the stuff that allows us to do A/B tests and things like that. I serve as sort of a tech lead there. I also do sort of a random grab bag of eng leadershipy sorts of things. I was, I think, one of the founding members of the Reddit's principal group, which is the group of principal engineers that talks together about a bunch of different things, like how to do various engineering things, and also like how should we have greater cohesion of Reddit engineering as a whole, especially at the very higher levels. Separately from all that, I also do some sort of administrative kinds of things where among other things, I run many of the classes that Reddit Eng onboarding people go through. So people, as they come into Reddit, like basically every company, has a sort of tiny little university that runs for a couple of days, telling people not how to do software, because we assume that people already know that by the time they show up, but rather how do you do software at Reddit, right? And that's really fun. It means I get to meet basically all the engineers on the way in, and it's also an amazing venue for propaganda. So I found that that's like a really valuable thing. Interestingly, all of those things, or two of those three things that I just described, were things that I complained about Reddit doing badly when I was visiting Reddit in the very beginning of my days. And I was like, "Hey, y'all seem to be sort of stinking up the joint on these four things." And they were like, "Oh yeah, okay, cool. There's like people working on various pieces of that." And then in some cases I came in and ended up, sort of getting to work on that really directly.
Yeah, that's actually how we met. You taught my class.
Yeah.
So
and that, like, this interaction is actually a great example of why being involved in onboarding is such a great idea, right? Because it gives you so much interaction with people who you otherwise probably would never meet, right? And that has at least two or three different effects. One of them is that it means that you get to meet a lot of people. And that means that if you need somebody from somebody in the organization, the likelihood that they will have at least some memory of you and be like, "Oh yeah, you were that guy who made all the jokes in the first and last, or in some of my engineering onboarding things. And therefore I'll be nicer to you than I otherwise would be." Like, that's a very high likelihood. When I've done this at a couple different companies. And at one point, my mother and I were walking through the mission, and three separate people rode by us on fixies and were like, "Yo, Matt Knox, what's up?" And my mother looked at me with like parental achievement unlocked, like icon over her head, and was like, "Honey, you're famous." And I got to say to her, "Yes, Mom. Yes, I am. In the mission only." So that stuff is great, but then also it forces you to sort of live in public a little bit because you're so visible. If you're dickish, it's really bad, right? Like people sometimes have a bad hair day and they'll be mean. And if you're being really visible, you kind of have to accept with that the fact that you don't get the same sort of buy that people can generally expect when behaving badly. And that's actually, I think, a really good thing in general. Forcing you to live in public a little bit tends to make you just better as a human being. And I'll take all the better I can get.
Okay, so today we're talking about experimentation. And so you have a long career in software. So I'm interested, how did you first get into A/B testing and experimentation?
Completely by accident. So I ended up at Twitter in 2009, and the second project I had was to launch Native Retweet. So what I mean by native retweet is the thing that you see today when you want to retweet things on Twitter. Before that, the user pattern had been to copy the other person's tweet and type out capital RT space somebody's screen name space the text that they were tweeting. But if that tweet was close to the maximum length of a tweet, which at the time was 140 characters, and now I guess is 280 or like a lot if you're paying, then you sometimes have to edit what the person was said, right? And you also could just make shit up, right? Like you could say like, I don't know, some outrageous thing. You could say like RT at Jack, Twitter should be regulated by the SAC and shut down or whatever, right? And obviously would not be true. And so within Twitter, there was this idea that it would be better for users. It would be way better for the spread of ideas and just generally a good idea to build actual native sharing functionality. This was one of the first places that really had that, right? Like Tumblr had Reblog, I think, around that same time, but I wasn't aware of it because I didn't use Tumblr all that much. And I think this was pre-Facebook Share. So this was a fairly early sharing thing on the internet. And so I was asked to build this, and that came with it. That was a relatively small UI change, but it had really profound changes for the backend. Because those changes for the backend were so profound, I had to build a library for Twitter, which we called Decider, which allowed us to roll the feature out to tiny fractions of a percent of all users. And the reason for that was that if we were to just turn it on for everybody all at once, it would have taken all the servers down and the site would have crashed and it would have been a disaster. And the fractional rollout system we had at the time at Twitter called Releaser was only good for doing percents at a time. And we were not at all confident that we could roll to an entire percent all at once and that it would just work. And we also wanted to be able... Twitter also had a second library at the same time called Dark Mode, which was just for shutting things off. And then, of course, finally, the interface for dealing with this was to go into Memcache and like set a string, and your string better parse. And if it didn't, the entire site would go down all at once with like nothing but 500s in like the blink of an eye. And so that was not great. Right. So I needed to finish the job of releasing Retweet. I needed to make this more ergonomic library that would both allow for blade switch type shutoff in case there were problems and fractional rollout. And it needed to be smart enough to know that we could set up a feature to be available to all employees as opposed to only a part of employees. Right. So there was this fairly complicated set of logic that was in there. So I built that, and that gave me exposure to half of A/B testing. So A/B testing as a rule is kind of like the MasterCard logo, the two interlocking circles of control and then data measurement, right? And by control, I just mean deciding which version of a given feature or a given thing you're going to get, right? And that is, at the time, I was only thinking of it in the context of basically access to a Boolean, right? Like, do you have retweet or do you not, right? And the answer was you do, right? In for the people that needed it. But the logic for determining whether you would have it was needed to be a little bit complicated so that we could opt all employees in, so that we could sort of bug test and everything like that, but had to be flexible and also had to be ridiculously performant. In particular, it could never make a network request ever, because we couldn't afford the extra network call in some of the places where we would be checking this. And so that meant that we had to use it only on things that were already available in the user, in like the user object that we had, because we always had access. We were building a timeline for a user. Which user? What do we know about that user? And so on that user context, we had all the information we needed. Is this user an employee? Is this user, like, what's the user's ID and so forth? So as I said, we couldn't do any network calls and we couldn't write anything ever, right? We had to just use existing data that was already there. And we had to make sure that we were able to do this consistent. There were a number of constraints, really. We had to make sure that as we rolled up the fraction of users, like when we went from 0.1% to 0.3%, the 0.1% that were already in, they have to stay in. It would be really bad if they were just flailing around, right? Like if it was like, oh, 0.1% or 0.01% randomly get the feature. And now we move up to 0.03%, but it's a new randomly chosen, unrelated 0.03%. That would be a disaster, because people would go from seeing native retweets to not, and then going back every time it rolled up. That would be incredibly bad. So you had all these properties that you had, all these constraints you had to resolve. And the process of shipping retweet was substantially the process of finding the right cuts through a bunch of these constraints such that we were able to ship it and it was relatively performant and didn't break too much of anything. And that was introduced me to the control part of experimentation. And very shortly thereafter, I started getting into the data side of experimentation, which is the other half. The other circle in experimentation is getting the data measurements. And so I did that in an ad hoc way for the retweet feature. And then subsequently I worked on it much more in later iterations of that.
And did you, like at Twitter, did you mainly, after you did the retweet stuff and built this, did you continue on that? Was that kind of your
No, I did a really bad job of career management. What I should have done in retrospect is maintain and make awesome, or at least not as janky as it initially started out, the decider library and all that stuff. And so, like, if I had done that, I would have had a much like bigger, more like staff engineer promotion worthy kind of career at Twitter. But what I did instead was I said, okay, I shipped this thing. It sort of obsoleted both the dark mode and the releaser libraries, and therefore I should go and get rid of all of the other. I should get rid of all the calls, like all the call sites of dark mode and releaser, so that there's nothing left but decider. So I did do that, right? Like I got rid of the tech debt the things that I just obsoleted. I got rid of all of that. And what I didn't do, though, was I didn't then say, oh, okay, now let me just make this let's make this super pro style and keep iterating on it.
You've kind of given it a little bit already, but I'd love for you to kind of, like, from your vantage point, explain when we talk about experimentation in software, how would you explain that? And like, what does that encompass?
Yeah. So as I said, it's the intersection of control and data. And really, each of those things is interesting in its own right. And it's completely in its own right. And by control, I just mean deciding what version of different features people get. And that can be, and the notion of a feature there is really broad, right? Like, what timeout should you use when calling to this backend service, right? I don't know. Maybe you think it should be 200 milliseconds, but any roundish number like that should be viewed with a bit of suspicion, because that probably means somebody just like pulled it out of their butt and they were like, I don't know, 200 milliseconds. That sounds fine. Right. And it's frequently the case that tuning those things can generate a lot of value. Right. So one could imagine doing an experiment where you said, let's do an A/B test where we try, I don't know, 20 different values of what this number could be, right? The 200 is the basis. That's a control that we just was like a prior. Somebody decided that's probably okay. And let's go up and down in increasingly large increments in both directions, right? So let's try, 150 and 250 and so forth. And then try that in a bunch of different ways. And then what you'll see is there'll be different behavior. That's the control part of it. And that also applies, of course, to things like, let's change the color of this button, or the text on this page, or whether this page exists at all, or whether this subsection of the page is going to be there, all those kinds of things. And then there's the data side of that. And that is, let's see what happens with user behavior when we try that. Now, a reasonable follow-up question to that is, what do you mean? Like, what kinds of behavior do you want to track? And the answer to that is part of why I love experimentation engineering so much, because experiment engineering deals with it's generally one of the highest query rate systems in the system that you're running, right? Like, of the subsystems in play, the experiment, the thing that decides which version of what you get, tends to be a very high query rate subsystem, right? So it tends to get called way more than one time per request, sometimes thousands or tens of thousands or millions of times per request. And so it has to be it's a really, really, really high throughput system as a whole, right? And at the same time, it tends to have this really broad applicability, right? Like it's kind of everywhere, but it also requires you to really understand, what does the business care about? What does Reddit really care about? A kind of basic answer would be to say, oh, well, Reddit's a social app, so it cares about engagement. So people engaging with the app, and also time on site, because time on site, generally speaking, will correlate pretty strongly with the opportunity to show ads. And maybe we should look at ad showing like as its own thing, right? And then you number off a couple of those things. But when you kind of tunnel in on any of those questions, each of those metrics becomes really interesting. What do you mean by engagement? Do you mean reading? Or do you mean voting on stuff? Is voting on stuff, or is it commenting? Is it content creation that you could think of as engagement? Like, am I engaging with a post by do I have to be voting on a post to engage with it? Or are you going to score as engaging with a post just me reading it for a long time? And then to be able to know that I was reading it for a long time, now you have to collect data in such a way that you can tell that I was reading it for a long time. And that is not at all a trivial thing to do. Just that tiny example I gave gives you a feeling or like a glimpse, I think, of some of the many ways that experimentation engineering is such a deep and broad discipline, in that you have to, as an experiments engineer, you have to be at least a little bit involved in how you collect data that you're going to use to build metrics. Then you have to be really involved in a very businessy, producty kind of way in what those metrics should be, right? One example of that is, should you just have one metric that's some composition of these various other metrics, right? You've got a feature that's good for engagement, but bad for ad showing. Is that good or bad? I don't know. Kind of depends on the respective values of those changes. And so that is why experiments engineering is such a fascinating discipline.
When you're talking about experiment engineers needing to understand all that stuff with the business, that makes me start to wonder, like, when experiments are being, I guess, like thought up or designed, how much of that is would you say is engineering versus how much of that is like product?
It's a really interesting question, and it depends a lot, right? So if you're doing a thing that is, let's do experiments to change the timeout on a call to some service. Or a slightly more realistic example is, let's change the ad load. So ad load is how many ads do I show in a given body of content that I'm going to serve up. So maybe Reddit serves you 20 posts at a shot in some surface, right? Like you go to your home feed, here's 20 posts. How many ads should be in there? Right now, the answer is 3, say. I don't actually know what it is right now. It's probably a complicated function, but let's just serve up 3. Cool. So now let's run an A/B test on that, running values from 1 to 7. And we'll see like how those shake out. For that kind of question, there isn't very much product in the sense of how do we design the screens and let's build up the UI and all that. But there's a substantial amount of how do we want to think about what's going to go on for users and come up with hypotheses, right? So what's my hypothesis? A sort of 0th level approximation that I would have for that kind of experiment in a company that I didn't know very well would be probably less ads will be slightly good for engagement and very bad for revenue, right? And by contrast, lots of ads will probably be somewhat bad for engagement, but I don't know how much, and probably very good for revenue. But interestingly, how good it is for revenue will depend on a bunch of really abstruse things, like how good is your auction density? So imagine you have a small number of advertisers and they each only want an ad to be shown to one person one time in a given day. That's a pretty common kind of situation. If that's the case, and you don't have a ton of advertisers, then your highly engaged users, allowing them to see 7 ads may not actually show more ads to them than allowing them to see 4. Does that make sense? Because like you're at 4, you're going to run through all of the ads that could possibly be shown to them. So allowing yourself to see 7 just shows them a lot of ads and then no ads. And so to know that, so if you're designing the metrics around this, not the metrics of the overall experiment system, but the metrics around the revenue, like building up the revenue metrics, you've really got to get in and get deep in all the relevant details of that subsystem to be able to decide what metric you want. It's super wild.
You mentioned that part of experimentation is data, so control and data. And so the data collection becomes really important. And it appears to me that the data collection is not a part of the experimentation platform, or not considered experimentation. Yeah, it's like you collect in something else. So how does that like interact? How do you interact with like whatever data collection platform is being used?
Most platforms need to collect data just for their own purposes outside of experimentation, right? So as an example, most of them are going to care about what their daily active users are, or like how much aggregate time on site did they have in a given day, right? And to do that, they're probably going to collect some kind of event that says give user A was on page B at time T. And there'll probably will be some data collection from that collects all that data up, and then probably some sort of directed acyclic graph of worker processes that take that data and refine it into successively more interesting sort of higher Shannon entropy metrics over time, right? So like you can take that and you can take the trillions of events maybe that happen in a given day, and you come out with a single thing that is how many user years were spent on this site today. It is almost always going to be the case that the business will care about many of those metrics. And then it'll typically be the case that you will care for a given experiment about what the subset of users that were in the new treatment versus the control being what you were doing before, and the treatment being the new thing you're trying out. Or maybe there's many treatments, but in the one or more treatments versus the control, how did those metrics do? So you need a way to sort of partition this data that was, you need to partition the data to report on that bit of data in one group versus this other one. So the way that tends to interact is you tend to have to get in kind of in the middle of that process. So we were talking about we're emitting events that say that a user U is on page P at time T, cool. And then there's a thing over here that says, this is how much total time on site was spent today. Probably about 3/4 of the way towards the end, there's going to be a spot where you're going to say like, oh, there'll be a table somewhere in whatever our data store is that says, here's for every user we have, here's how much time they spent today. And then we're going to sum that up to get the full day. So that would be where the experiments folks would tend to slot in to make that metric, because they would say, oh, we know which users were exposed to a given treatment or control, like a given variant, which would be either a treatment or control. We know who got exposed to which variant at what time, and therefore we can calculate the subsetted version of these metrics fairly tractably.
So you came to work at Reddit, aside from your boss saying make Reddit better, I'm guessing that you gravitated toward A/B testing, but I'm curious, like, what did A/B testing look like at Reddit when you joined, and how did you get involved in that?
It was pretty disastrous when I got here. So there was an A/B testing system. It was fairly lightly used, and it was a very, very long and laborious process to set up an experiment. I think there was like a 30-step, there was a wiki with like a 30-step process. And one of them was generating a UUID in the terminal. And another was to insert a line into a Google sheet that was used to keep track of what experiments were going. And then you would manually write the JSON, the config as a JSON blob, and insert it into an INI file that was loaded when Reddit private, which was the private bit of Reddit, which was Reddit public. So you'd write the JSON into the INI file, and then that would cause experiments to happen. And then you could write the code that would say, if for this experiment, I'm in the enabled group, go over here. If I'm in the control, go over here. And then once you've done your thing, you would then have to go like corner or bribe some data scientist and get them to run queries for you to tell you what was going to be the thing. So that system was disastrous on a whole bunch of cases. One of them was that if you wanted to change anything, if you wanted to bump a given feature from 0.1% to 0.2%, you had to do a deploy of R2, which was the main Python monolith, which is not great. Assuming there was no deploy contention, which was never the case, but even assuming that, you were looking at like an hour. And that meant that if you shipped something that was disastrous, then it would take you an hour to undisasterify that. And that's just like straight up unacceptable. So the changes that I made for that were to make a web UI that would allow you to make changes that would then get reflected to the various places. But when I say reflected, what I mean is we would instead of having you hand write the JSON for the experiment config, which by the way was extraordinarily error prone, right? Like people would just mess up all the time on that. We made a UI that would generate it for them. That was like enormously better. And then we would write that to Zookeeper, and then all the various front ends, like the R2 front ends and whatever, all knew to listen to Zookeeper already to pick up some live data configs. So we used the pre-existing live data config and this facility to write an experiment config to pull that down and make it expose that to everybody. And once we had that, we then had a system where whenever a system would come up, whenever a new R2 front end would come up, it would know to fetch the experiment data from Zookeeper. And anytime it changed, Zookeeper would change, and it would know to pull from Zookeeper and pull down the new version of that data. And we pretty much were off to the races. And this meant that the experiment system, the system that actually wrote the configs, only took requests at the rate of people changing experiments, not at the rate of people wanting experiments. So we had completely decoupled the reads and the writes on this, which made it a tractable problem. Because then it didn't matter how many, like we didn't care how many servers there were pulling us. We didn't even know. And so that was really handy.
That feels like, to me, maybe an evolution of the old system, but
100%.
Pretty sure that we have a whole new system that came after that.
Yeah, that's true. Like that, as an example, like that piece of that system eventually evolved. Like now there's way more people querying for way more services just available. Lots and lots of things want to pull the experiments data. and the rate at which we create and modify experiments has gone up, like conservatively a factor of 100 or so since those times. And actually, no, more, probably about close to 1,000x, I think. And so that means that the storing the full data in Zookeeper is no longer tractable for us, but we made an incremental change to that. We write to S3 and then dump the S3 path in Zookeeper instead. So instead of fetching directly from Zookeeper, you just fetch this like big ugly URL and then fetch that from S3, and it's basically the same system otherwise. But the rest of the things that had to happen were we had to instrument initially just in R2, but then very shortly thereafter in D2X. We had to make it so that clients that were not R2, that weren't sort of a Python baseplate is Reddit's sort of base library for building services, initially in Python, but now in other languages. We had to also make that available in JavaScript for D2X, which was at the time the redesign, the new at the time redesign of Reddit that launched starting in 2017, 2018-ish, right? Like it was in implementation for a year and a half or 2 years or something like that. In 2018, in like June, I think, they said something along the lines of, hey, we're going to do a launch of this D2X thing, and we need experimentation. And you've been a loudmouth about how you think we should be doing experiments, so you should maybe go do that. And so I said, yep, cool. How long do I have? And they said 4 weeks. And I was like, you mean 4 weeks like for the design doc? Or they were like, no. 4 weeks to run the first experiment, to start the first experiment from like a standing start. And so that was tightish, but doable. So we built the UI, we launched that. We even took the probably dumb technical risk of launching that as like a Kubernetes service, as opposed, which was new at Reddit at the time, rather than launching as like an OG style service. And then we built the integration. This was me and Mike Doherty, who's now running a big chunk of search, or the two sort of main engineers working on this part of it. Then he worked in the code to do the Python bucketing and everything like that, and got that integrated both in R2 and in GraphQL, which had just come out. And so D2X was a Node.js service that got some of its data from GraphQL. And so we could have implemented the same bucketing code in JavaScript, but making those be identical is non-trivial, and we expected there'd be a fair number of changes. So we instead had D2X call GraphQL, which was itself written in Python, to get the experiment bucketing. I was not happy about that, but it was what we got it was a thing that we could afford to do in 4 weeks and get it landed. And I trusted that, and I trusted that we could do that because there was already some mostly working pre-existing Python code, and I trusted us to get that, like to expose that in GraphQL pretty like that. I knew we could make happen, and so that worked. And then that carried us for many, many years. That carried us for about 3 years, with many sort of incremental expansions. We wanted to start doing A/B tests in Android and iOS. We just had them call GraphQL 2. We wanted to do, anytime we had that, some first party client rather wants to do experiments, we would just have them hook up to GraphQL, and that basically solved that problem. At the time, there was maybe like a quarter of an engineer deployed to this full time, in that it was like 10% of my time, 5-ish% of Mike Doherty's, and a little bit of Andre Von Hook, who's in the data platform team now, and he runs Andrelytics, which is a UI that is used by our salespeople to generate various kinds of graphs. His involvement was basically to build the readout part of this, which fortunately we had longer to do, because you start the experiment on day one, you got like another week before you need the readout at the earliest.
So you've started talking about how these different clients were using GraphQL to get experiments, to get like, should the button be red or should it be blue? Reddit, it's a bigger site today than it was back then, but even back then it was very big. And within each kind of request or code path that a customer might make, there's going to be many different experiments that are asked for. So how in the world did you make that happen so that, everything was performant?
So it's the same principles that I had to do with cider, right? And that is, like I just said, as like an iron rule, we never get to make a network request in the process of deciding which bucket somebody's in. We just can't. That's just how it works. And so that means that you have to use the data that is available to you on the sort of the user context, right? The request context, which will tell you like what's the user's ID and are they logged in and a number of other things like that. What's their geo was probably on that in most cases. And you also can have other data, but it has to be a chunk of data that you're fetching not as part of that request, but just in general, right? So it's fine to say, as an example, hey, my service, when I spin up, let me fetch the experiment config, right? That's just part of me spinning up. It's already going to take many seconds for me to spin up. Look, checking in Zookeeper in a known place, seeing a URL, fetching that from S3, and then barfing if I can't do that. That's totally legit. Although a notably interesting thing about experiments is it can be designed to fail open, which is to say, if you fail to fetch the experiments, just assume every experiment is turned off. And that's fine. But in the general case, you fetch the experiment config, you got it down locally, and you're like, okay, cool. This is the set of features. I'm good to go. And then you could say, now I want to see what users get what features. Having the config of the experiments with a fairly flexible configuration language that says this experiment goes to all employees and 3% of all users as long as they're in either the United States or New Zealand. Like that is a sufficiently complicated, it's a sufficiently expressive configuration language that you can then use just the user context, the edge context, the context of that user's request and the config data, and you have all the power you need. Now, there are cases where people want more than that, but we made it through 5 years with just that, and the adding extra things, we can basically take the same approach. Like right now, there are some teams that say, hey, I want to do some experiment with like where I manually say these 5,000 users should be in this experiment, in this treatment, and these other ones should not be. We can make that same thing tractable, but we have to do a little bit of engineering to sort of make sure that that data is available on all the services that need it, such that they're like good to go for that. We can spend a frankly not particularly significant chunk of time bucketing users into all these different features that we want and not have much impact on performance because we made sure we're never going to make a network request, and then we're just good to go. Works really well.
So that is not making a network request from that kind of experimentation service.
Yeah. In particular, not doing an individual network request on every point where you want to say, should I go this way or should I go that way? In the best cases, we don't do any network requests at all. In the second best cases, we start at the very beginning, batch request all the experiments that a user might be in, hold on to that data. As an example, in the D2X case, that's what we do. A user comes in, they're in JavaScript, they can't bucket in JavaScript, so they will call out to GraphQL, get all the experiments they might be in, and hang on to that. That also happens in iOS and Android because we don't yet, I hope to have this soon, we don't yet bucket in situ on the device. And then we can say like, okay, you paid that request, you paid that time in the setup of the request, right? Like the request comes in, you know what the user ID is, you're sending it off to GraphQL, you get the bucketing back and you bring it back. But then you don't have to make a request every time you run into one of these, which feature am I in?
Okay, cool. So do the clients configure like the time to live for that, like how long it's going to cache those experiments?
Yeah, so that's a great question. Usually what happens is they'll use it for the duration of a session. So as an example with D2X, it will calculate, D2X is one of those hipster JavaScript isomorphic web apps that's like rendered in Node on the server and then comes down to your browser, right? And so they bucket you into all your experiments and then send down to the client which experiments you're in. And they also, because it's one of these React apps, it's got the code that decides like Like here, you clicked on a post. Let me just render the post for you. And I'll render the post, and there'll be code in there that says, oh, if I'm in this experiment, make the post button blue or whatever, like that, right? And that code then doesn't have to call back to a server to find out what bucket you're in, because that's again hanging out on the client. So there's like levels of nesting of caching here, if you see what I mean. Likewise, for iOS and Android, generally speaking, they don't want to change experiments mid-flight because they're worried about that causing various kinds of crash. So what they will typically do is fetch the experiment bucket list, or fetch the map of experiment feature names to what variants you're in, app boot, and then hang on to that until the next time the app has to cold boot. The bucketing used to all be written in Python. Now it's written in Rust. And because it's written in Rust, we can compile it to run basically anywhere. So we can run it in, say, we can run it in Python by wrapping it like you would wrap any C library. We can also do it in Node.js, right? So so we can also do it right there. And we can also eventually do that in iOS and Android. And that kind of stuff will probably happen over the next year or two.
Was the ability to run it within any kind of client the reason you wrote it in Rust?
It was really the reason was, I mean, fundamentally, when you think of experimentation as being control and being like, I need to be able to control stuff everywhere and like to be able to capture data about things. And you realize that though each of those things is valuable on its own, like control is valuable on its own without the data, like just turning features on and off or like shutting things off because the site is degrading and you need to turn off this expensive feature. Like that's a valuable thing, even without experimentation and without the data. Likewise, the capturing data is a valuable on its own, of course, too. Since you want the control everywhere, that means you probably want to have, you're going to want to have the same control system available pretty much everywhere. Like it'd be kind of lame if you had to go to one place to turn off features in D2X on the server and a different place to go to turn features on and off in D2X the client, or Android the client, or iOS the client. So you kind of want there to be, in principle, you could have many different systems to do this, but it's pretty nice to have one. And thus you want to have the same bucketing library that determines which version of something you get. You want exactly that same code in lots of places. Now, okay, that's fine. So if you want exactly the same code in lots of places, you basically have two options. One is you can implement the same code in a lot of places. I have seen that happen a lot of times, and I have never, I am told that Facebook made it work, but I'm dubious. I saw Twitter try it a lot of times and fail, right? Every single time. Now, it wasn't like a disastrous failure, but typically there were edge cases. And if you're going to have moderately rapid evolution in the capabilities you want from bucketing, then that will be potentially challenging. So one alternative is to build it everywhere. And the other is to build the code once and then expose that code everywhere. And so if you want to build once and expose everywhere, that basically means use something with a C ABI. So that's the application binary interface. So like how do you write a gob of code in C or something, or in C-ish, and then wrap it in Python, wrap it in JavaScript, wrap it in Android, wrap it in iOS, and so forth. But probably don't do it in C, because pointer arithmetic can be kind of a problem. And if there was a problem here, if there was some kind of like bad buffer overrun kind of situation, you could imagine that hitting every possible service you had all at once, and that's a disaster. So you basically want something that compiles to a C ABI and is extremely safe, and ideally also something that Reddit also has experience doing. And for that particular trifecta of criteria, the only language was Rust. So that's what we did, and it worked out beautifully, right? Like it was the Rust code for it was pretty nice and fairly small, and the embedding of Rust into Python was quite easy. The embedding into Node.js was quite easy. Go is kind of an antisocial language that doesn't want to embed anything either in itself or embed in anything else, because it is like a weird runtime set of issues. But it works fine in iOS, works fine in Android, works fine pretty much everywhere.
You mentioned that with a lot of the clients, when the user session starts, they're caching the experiments that client is a part of. And so that client has a consistent experience likely as they're moving through what they're doing. But I'm imagining that the bucketing of users, you want it to be like kind of deterministic in terms of, you had mentioned it at Twitter, you wanted the same 0.01% people to continue getting those retweets. So is there a specific way that you're like accomplishing that when you look at a percentage rollout?
Yeah, it's like embarrassingly easy once you, well, it's embarrassingly easy once you have it. And it is to take the name. Okay, so here, let's list the features we want to have. So we want to have the same, as you raise the number of the percentage of users in a given feature, you want the users who were in first to still be in as you rise up in general. However, you also want to be able to shuffle users among the buckets, right? So if, as an example, you ship a bad feature, it has a terrible bug, it's crashing everybody all the time, those users have had a bad experience, and therefore you don't want to use them as the basis for comparison to something else because they've had a bad experience. So you want to shuffle that. And you also you want in general experiments not to be correlated with each other. So I have an experiment A and an experiment B. If I'm in the first cohort of users that get the experiment A, I shouldn't also be the first cohort of users that get experiment B, because if I did, then you think you're comparing A versus whatever the control, whatever it used to be, but you're actually comparing A plus B versus the control. And that may not be the right thing, and that isn't the right thing. So it turns out that what you want then is something that will have a unique shuffling of users among the buckets per experiment. And the way you get that is you make a string out of the experiment name, the identifier that you're using, like usually it's going to be user ID, but sometimes it's other things. And importantly, a shuffle version, which is a thing that you increment anytime you want to shuffle the users around. And so then that gives you a string. And then if you SHA-1 that, you'll get a not cryptographically secure hash, but a like very even bucketing across the various buckets. You then take that number modulus some big number. In Reddit's case, it's 1,000. In Twitter's case, it was 10,000. And then you say, oh, okay, that I took that string, I SHA-1'd it, I mod 1,000 to that, and now that tells me what bucket I'm in. And then I just say, I'm going to start from 0 and extend the buckets upward for the first feature. And then you imagine you would just have a single feature experiment. I'll just extend from 0 up this way for the treatment, and the control will just extend downwards from 999 or 9999 for Twitter. There are a bunch of complications for this. Like if you want to do multiple variants, a way to do this is to express your buckets as ranges. So treatment gets 0 through 100. That would be 10% in Reddit scheme where there's 1,000 buckets. And the control gets, say, 0 through 100 half open interval. So 0 through 999, or 0 through 99, not all the way up to 100. And then the control gets 100 through 200. And then if you want to make those larger, you can add extra ranges that will say like this range is also in the treatment and this range is also in the control. The stuff you need to populate that is just what's in the config, right? Like what's the shuffle version and what are the ranges that we care about? And what is the stuff from the user context? So what is the user ID usually?
Okay, well, thank you so much for giving me a wonderful overview of everything that's going on. Not overview, you got into a lot of details, which I enjoyed. Any last things you wanted to say?
I think that experimentation engineering is maybe the most underrated field in technology, in that it is both stupid broad. It just like covers, you have to understand the breadth of your business, the entirety of your product. A lot of human stuff, like, but then also really, really fine details in the infrastructure, kinds of things. It's really hard. It's really, really valuable pretty much everywhere. And so I think everybody should care about it a lot more. And I think that's being borne out in the marketplace basically continuously. And also coming to work at a company like Reddit is where it's a very large scale, not so large headcount, and where it has a history of being undertooled, is just like incredibly fun because you get to do just such big, you get to take such big swings, which is really fun.
Lots of opportunities.
Yeah, because it's a very target rich environment for like, oh, Reddit has 10 million daily active users and no experimentation system. That's wild. You can just fix that. And then you get to be the person that just like built this system. And it's kind of cool.
Great. All right. Well, thanks for your time, Matt, and appreciate it.
Yeah. Thanks so much for having me.
So what do you think? Does it sound cool to build Reddit, one of the largest sites on the internet? If so, check out our open positions at www.redditinc.com/careers. And to get more behind the scenes info, check out Reddit's engineering blog at reddit.com/r/redditeng. And that's it for now. See you in the next episode of Building Reddit. Building Reddit is an official podcast from Reddit. This episode was produced by Ryan H. Lewis. Thanks for listening.